Hello, Hornets. Welcome. Today we're going into part two on improper integration. And what we are looking at today are a couple of problems. The first problem that I have for you is the integration from 1 to infinity of 4x to the negative 1/4 power dx, or the integration from 1 to infinity of 4 divided by x to the 1/4 power dx. Now we're going to assume for the moment that we do not have the information that we went over in part one, because according to our information in part one, we have approaching infinity, but our power is between 0 and 1. And according to our kind of rubric that we had, if you recall, looked like this. We said that when I'm going to infinity and my power is between 0 and 1, I'm going to get something that diverges and no sum is possible. So we want to just demonstrate that that's indeed what we are going to get and that we can utilize this without having to fear. So seeing that I have going to infinity, I'm immediately going to start my limit as b approaches infinity, 1 to b. This is what we have to do in order to work with the improper integral, and that's working with limits. So we take the limit. We can now move the 4 in front, 1 to b, limit as b approaches infinity, and I can integrate this normally. As I integrate, I'm looking at 4. I'm then multiplying by 4/3, the reciprocal of the new power, and when I added the 1, I ended up with 3/4. And we're going from 1 to b for the limit as b approaches infinity. So this is what we're working with. Now, when I plug that b in, I'm going to write my limit statement, 16/3, b to the 3/4 power. That's infinity to any power is growing. Meanwhile, we have this 16/3, and this is 1 to the 3/4 power. So as we apply the infinity, we get infinity, and we're subtracting 16/3. 16/3 taken away from infinity doesn't change anything. Our answer is infinite. Therefore, there is no sum. This had to diverge and is divergent. Now, once again, this is why we use the chart. Who's going to want to go through all of this work if we already know at the onset that it is going to end up diverging and equal infinity? Now, unfortunately, not every problem can be identified. So sometimes we just have to go through the process even if we don't like it. Look at this one, for example. 0 to infinity, x e to the negative x over 3 power dx. Here's an example where it doesn't fit that rubric very easily, except that we're going to infinity. So if I'm going to infinity, I immediately let the limit as b approaches infinity for 0 to b. Now we're going to have to use integration by parts with this. So I'm going to go ahead and I'm going to let my u equal the x, and I'm going to let the dv equal the e to the negative x over 3. We then take the derivative of u twice, and as we take the derivative of this e to the negative x over 3 power, we get negative 3e to the negative x over 3, and then positive 9e to the negative x over 3. Plus minus, we work along the diagonal, and we're now looking at this equaling the limit as b approaches infinity, and I'm looking at negative 3x e to the negative x over 3 power, and I'm subtracting 9e to the negative x over 3. This is going from 0 to b. Plug in your b. The limit as b approaches infinity, and I'm looking at negative 3b e to the negative b over 3 power minus 9 e to the negative b over 3 power, and then I'm subtracting. Negative 3 times 0, e to the 0 minus 9 e to the 0 power. Now by Feppel, notice this is negative 3b over e, so that's like negative 3x over e to the x over 3 power. The e to the x over 3 grows faster as we move toward infinity, and therefore by Feppel, this goes to 0. The same thing happens with negative 9 over e to the b to over 3. By Feppel, this also goes to 0. And when we distribute the negative, we have plus 9. Therefore, my answer is 9. This limit, or this integral, is equal to 9. Notice, this was a hard one. We couldn't immediately use our matrix, if you will, to identify whether we're going to diverge or converge. The only thing we could do is work it out. And that's one of the problems that we have to face. So please be aware, as you are doing this, make sure you take your limits as b approaches infinity or b approaches 0 from the right and go through process. Thank you very much. I hope you have a good day. Please take care. And remember, it's easy to be mean, so please work harder and be nice to each other. Thank you very much, and please be safe.